Hello, everybody. Thanks for being here. A little bit about me. I've been working in startups for more than 13 years. I've done a lot in startups from front end, back end, infrastructure, security, marketing, and so on. So I know all the nuts and bolts when it comes to startup building. Today, I'm going to talk about spec-driven development with Cloud Code. Obviously, there are a lot of other AI models that everybody could use. GPT, I don't even have it in my memory because I don't even use it. So I'm going to focus on Cloud Code and its specifics. Imagine that everybody from this room, even if you are a developer or not, everybody used AI. Like you want to build an app. Hey, I want to build this Uber clone. Make me $1 million founder. Please help me do this. And this is the dream, right? You describe the app, the feature, and you press enter and the AI starts doing things and you hope that it ships it. But the reality is that, well, at first hand, the AI is right. But as the context grows, as the app grows, as you have more components, more services inside your project, then the AI start missing stuff because this is a known limitation of LLMs. You cannot cram too much information into its context window. And if you even cram too much information into it, then it will start messing it around. So it's not that smart. And it starts ignoring existing patterns. It starts installing the wrong packages and versions. In real world scenario, I had like a test failing 5 times. The LLM said, hey, you are failing 5 times. We better delete this test because now it will pass. That's stupid, you know? But the missing link is that you need proper configuration inside your project. You need proper tooling and proper workflows that an AI can work with. This is what we are going to present today, and it builds upon what Andy presented earlier about context engineering, because this is what we are actually doing, context engineering, but in a more programmable way. By the end of this presentation, I published a Cloud Code plugin that you can install in your project. You will be able to apply all these best practices that I'm going to talk about in this presentation, and you will have all the goodies inside your project. So this is what we are going to build up to. We are seeing a paradigm shift, right? In the past days, humans were writing the code, humans were reviewing the code, and we just shipped code. Today, we see that we want to write code using AI, and you just prompt the AI, hey, build me this cool feature, and the AI is going to do that. But then the human struggles to review that code. I don't know how many of you actually review that code. I said, it's okay. The meme with that guy who does the security check. So this is how AI does it. What we are trying to fix is exactly this problem. And the new paradigm that I'm trying to promote and talk about today is the following. The human should do one simple thing. You just describe the feature. Hey, I just want to build this cool dark theme feature, or I just want to implement some playing cats on my landing page. So the human just prompts the AI the feature. But then what we are building is a full pipeline where you have an AI that writes the specs, then the AI plans based on these specs, the AI implements, then we have some guardrails. You have machines verifying this code, and only then you ship. So you ship with confidence. When you actually want to ship something, you actually do it without any kind of bugs. And this is what we are trying to do. So vibe coding fails at scale. It's because, as you know, LLMs are fucking stupid. They don't fucking think. That's just marketing bullshit. LLMs are just statistical models. And as you know, if you play enough with LLMs, you start seeing that they start inventing files or API names or, I don't know, signatures. They mix patterns from different LLM, from different frameworks and so on. The way they think that they fix tests is by just deleting them. That's fucking stupid. And they ignore conventions because your project doesn't have conventions. So this is what we are trying to do today, have a project that you can start with and injecting conventions into it so that you can happily code and ship features on top of that. There are some stats. We see that 45% of the code that is being written by AI is faulty, has security bugs. And this is even more interesting that people that use AI in their own projects actually spend more time talking with the AI, and the development time gets slower on familiar repos. What that means is that you use the AI in your own project, you start battling with the AI because you start introducing bugs, and you need to steer it to make it work. It wastes time using AI in your own project, and we want to fix that. There is something that we researched, and there's actually a model named the Swiss cheese model. And this is something that it is called defense in depth. What that means is that you cannot just presume that you just talk with an AI and think that it can do everything that you want. You need to implement a proper model that can accurately implement the features that you want, but you need to properly align it to your own desires and to limit it to the context of your project. And there is no a model or plugin, or I don't know, there is nobody that is teaching you this, and there is nobody offering you this. We see that there are different layers when it comes to this Swiss cheese model that we can apply to our projects. You can align your AI with such practices that are going to make an AI fail-proof at implementing bugs. You want to limit the scope of the AI, and you want to limit its room for error. And we can do it in multiple layers. One layer is, imagine instead of using just one agent to implement your feature, you have 3 agents competing for the same feature. So you are going to say, hey, you are developer 1, 2, and 3, and please implement the same feature for me, and we are going to pick the best candidate out of these 3. So this is layer 1. Out of these 3, we're going to pick the best one. Then layer 2 is the deterministic guardrails. It looks fancy, but it means it talks about Claude hooks, if you know about Claude hooks. It just means please run tests and type checks and contracts and when tool usage is going to be made. We are going to talk about that in the following slides. What is important? Human defined intent. So the shift is that now humans describe the feature that you want to be implemented, and the AI writes the specs, and also the AI writes the code. Moving forward, we also have scoped permissions. We are going to see about that later. We don't want the AI to do bad stuff in our code base. We want the AI to just handle. If you give an AI a task about, hey, please implement this front-end feature, it shouldn't care about your keychain inside your Mac OS. So you need to have proper permissions. And then adversarial verification, it's a fancy word or term of saying that, hey, we have one agent that does the coding, but then I want to have a clean slate and have another agent that cleanly reviews what this other agent did. So this is how we can actually implement this Swiss cheese model, where we want to make sure that the code that we produce is actually bug-free. I'm a fan of Claude Code. I'm not a fan of universal agents. I'm just into cloud code. You have the Claude.md, as Andy said in his presentation, where you have your project constitution. You don't want to cram your project, your Claude.md with too much information, because that is going to pollute your context window. And you want to keep it really slim. If you know how to leverage the way Claude works, you can have nested MD files, and you can have rules based on file matching patterns. I'm not going to get into the details, but the takeaway is that you want to have a slim Claude.md file which acts as a router, but not as a fucking novel. You don't want to put everything inside it. You just want to have it really slim, because you can then leverage how Claude works, and you can have nested things that will get loaded and picked up when you start developing stuff. Now we have the concept of rules. You want to have rules based on paths, loads specific prompts and agents depending on context. If you are going to load a .ts file, you want to load TypeScript related stuff. If you are going to load CSS stuff, you want to load design and styling stuff. By leveraging the idea of paths and globes, you can load the necessary rules task at hand, and this is done automatically by Cloud Code under the hood. So if you were going to look at what an agentic pipeline looks like, you have maybe an architect agent that reads the code base, writes the plan, it doesn't touch the code. Then you have an implementer agent that can do a test-driven development, has a test-driven development approach where it writes tests and then adjusts the code so that the test pass, which is really sane. Then you could have another reviewer agent that has a clean state, clean context, and it just reviews, it compares your current branch with your staging branch, and it tries to identify bugs and so on. And eventually the human intervenes and ships the code. When you ask an AI to do stuff for you, it will do stuff for you. Even if you want to find a bug, you say, hey, find me a bug. But even if there are no bugs, he's going to find the bug, even if it's not present. So we need to be aware of this behavior. And what we can do, actually, we can orchestrate three kinds of agents. You could have an enthusiastic bug finder, and a skeptical adversary, and a neutral referee that together can start looking for bugs, and eventually you could find those if they are real and present. If you are going to delete something, don't delete it. It's just simple. You want permissions to be generous but strict. You can edit files in this project, but please don't delete my photos. That's simple. Also skills. You can review reusable workflow templates. Nobody actually thinks about skills as workflows. So you can define the phases, like phase 1, do some testing. Phase 2, implement. Phase 3, ship, whatever. So you can use skills as workflows for Cloud Code. And now I want to introduce a new concept. It is called OpenSpec. It is a well-regarded project in the open source community. Using OpenSpec, you can ask the AI to implement features for you, but it is going to produce some artifacts, some files like to-do lists, architecture, design doc, and so on. And you can implement this in your project, but now with OpenSpec, you can have OpenSpec doing the product work and all the implementation phases and steps, and the AI is just going to follow those. So this is what OpenSpec does. And the full pipeline, we can see that we have the local development, a human describing the feature. Hey, I want flying cats on my first page. And then the AI goes and writes the specs and the architecture. And then the human just reviews those specs. And eventually the AI starts implementing that. And you could have like an optional reviewer agent that does PR code review. The defense in depth is more stuff. This is how a complete file tree would look like in a modern project where you have Claude implemented with settings, rules, agents, skills, commands, hooks, Claude, and so on. And the guys from Anthropic, who are the developers of Cloud Code, use the same patterns. They use the plan mode. If you use Cloud Code in VS Code, they write tests using Cloud Code so that you can only advance to the next step only if your tests pass, but without deleting your tests so that they pass. This is common sense. Context engineering. We see that at Stripe, all the PRs today are written by coding agents, and the humans just review and they just approve those PRs. So there is also an industry impact because seniors who already have experience in software development, their value goes up knowing how to use all of this shit. But juniors, like imagine a dude who just signed up for Automatica and he's in the 4th year and he fucked his life trying to go out of Automatica, and now he sees his life being replaced by some LLM. So that's really harsh, you know. But also juniors now need to adapt to this situation. And what you can do tonight, and this is what I prepared for you, if you want to, this is my blueprint in 3 steps. Reach out to bettertstack.dev. You can scaffold a modern task in monorepo. I prepared a Cloud Code plugin that you can install today. It is going to scan your monorepo and understand it and apply all these best practices that I talked about inside your project. And then just install OpenSpec, and you just need to ask it, hey, just build me that flying cats landing page. And this way, somebody asked the question, hey, how can we have a system that is constrained enough that can implement features without straying away from what we have to build? Well, this is the system, this is the blueprint that I've been working on. It is not going to fail. If you want to be confident in what you're building, this is the blueprint. You have the Cloud Code plugin that describes your code base, and you have the OpenSpec that makes Cloud Code implement whatever you need the right way. Humans are not going to write code anymore. They are going to define intent and constraints. The AI is going to implement those with the code within those constraints. And we have a deterministic system that verifies that the code produced is compliant and passes all the tests. Thank you so much.